In this video, we are going to do some more examples involving average value and finding the mass of a wire using integrals. All right, so our first example says the price of a penny stock is modeled by the function c of t equals 3t plus 1 over t squared. This is in dollars, where t is the number of hours since the opening bell at 6:30 a.m. Pacific time. And it says that t is greater than or equal to 1. So for this function, t has to be greater than or equal to 1. Question says, what is the average price of the stock between 7:30 a.m. and 9:30 a.m.? Okay, so it's asking about average price, so average value, remember is, I can write that as f average. The formula for it is you do the integral of the function, so from a to b of your function, and that whole thing gets divided by the length of the interval. So that would be, you do 1 over, and the length of the interval is b minus a. That's my average value. So for this function, it's called c. I'm going to call the average value c av. Okay, so I know I'll have 1 over something. What are the b and the a here? The endpoints of the interval. So if I look at the times, 7:30 a.m., this is 1 hour after that opening bell. So this is t equals 1. 9:30 a.m. would be t equals 3. It's 3 hours after that opening. Okay, so I'll do 1 over 3 minus 1 times the integral from 1 to 3 of my function, which is 3t plus 1 over t squared. And then I got dt. One of the big things that I'm hoping for us to practice with these examples is, practicing recognizing which of my methods do I use to do this integral. So I want to have you pause the video for 2 minutes to try this. That may not be enough time to finish the question, but hopefully to try at least one method or two to see, does it end up working? Does it give you something promising? So pause it and try it. All right, so hopefully you did that. Hopefully you paused it and tried it. How would we work this out? Well, this fraction can be simplified. I can split it up into pieces. It's 3t over t squared plus 1 over t squared. And that first fraction just becomes 3 over t. That next term becomes t to the negative 2. So then when I do the antiderivative, I can reverse power rule that thing. So we have that 1 over 2 in front. And then for this integral, I'm going to put a bracket. The antiderivative 3 over t is 3 ln absolute value of t. And then for the next term, reverse power rule gives me plus t to the negative 1 divided by negative 1. Close the bracket. Got to plug in the 1 and the 3. All right, so let's plug in, let's subtract. Notice the 1/2 is factored out of the whole bracket, so I'm just going to leave that factored out and just plug the 3 and the 1 into what's inside of the bracket, and then subtract those things. So I got the 1/2 factored out, it just stays factored out. Plug 3 in to get 3 ln of 3. Absolute value of 3 is just 3, so I can just write 3 without the absolute value. This fraction becomes minus 1 over t. So if I plug 3 in, minus 1/3. And then minus, now I plug 1 in. If I plug 1 in, I'll get 3 ln of 1. And then minus 1 over 1. Now I'll close that bracket. Okay, so I know ln of 1 is 0. If I simplify this a bit, I get 1/2 bracket 3 ln of 3, and then minus 1/3 plus 1 becomes plus 2/3, so plus 2/3. And then we can go ahead and distribute that 1/2. So that gives me 3/2 ln of 3 plus 1/3. So without a calculator, this is kind of as far as we can go. Units of price here are dollars. They are dollars. If we had a calculator and we wanted to round this, it turns out this ends up being about $3.15 if I round it to 2 decimal places. And there we have it. There we have it. Okay, so let's take a look at one more example in this video. Again, I'm going to give you an opportunity to pause it and to see if you can work out what the integral is. That is super important. That's kind of one of the biggest goals of our class. Can we get to the point where we're comfortable recognizing what method we use to do an antiderivative, and then how do we actually work out what it is? So this one says, find the mass of a rod of length 1 centimeter with a density rho of x equals x to the 7 times e to the negative x to the 4th grams per centimeter at a distance of x centimeter from the left end. Okay. So if we think about this rod, if I draw a picture, so it says the rod is length 1 centimeter. So I'm going to call this left endpoint at 0, the right endpoint at 1. And it's saying that if you go a distance, x away from this left endpoint, and you take that x value and you plug it into here, it tells you like what the density is at that spot. Okay, so we've seen earlier in this section a formula for the mass. The mass is the definite integral from the starting point 0 to the end point 1 of the density function, which here is x to the 7 e to the negative x to the 4th dx. So we're doing the integral. So mass is the integral from a to b of the density function, rho of x dx. We saw that earlier in this section. Okay, so the most important part of this is you pausing the video to try this. It's an important way to assess, well, how comfortable do you feel doing integrals like this? So pause the video this time for 3 minutes to try this. I mostly want you to think about, well, how do you get it started? Pause it in 4, 3, 2, 1, pause it and try it. All right, so hopefully you did that. Hopefully you paused it and tried it. Let us talk about it. So, okay, we can do this thing using u sub, at least to start. I'll let u be this exponent, and then du, the derivative of that is negative 4x to the 3rd dx. Okay, we might notice that, wait, I don't see x to the 3rd here, I see x to the 7th, but it'll turn out that this is going to be helpful. Let's isolate the dx. I'll get du over negative 4x to the 3rd equals dx. Because I have a definite integral, I got to convert these to be in terms of u. So let's do that. Okay. So right now I'm getting that x is 0 and x is 1. We're going to plug both of these into our u sub. So 0 plugged in gives me that u equals 0. If I plug in 1, I get u equals negative 1. So I get that this equals, the bottom limit is now 0. The upper one has become negative 1. So we still got the x to the 7th. Then we get e to the u times dx, which is du over negative 4x to the 3rd. Okay, so we can pull out the negative 1/4 in front. And then I got integral from 0 to negative 1. With the x to the 7 and x to the 3rd, they cancel a little bit, and I'll be left with x to the 4th. X to the 4th, and then I got e to the u du. So we still have some lingering x's, which is unfortunate. But as we've seen before with u sub problems, sometimes we can get rid of lingering x's by taking our u sub and using it again. Like if I isolate x to the 4th, I get negative u equals x to the 4th. And now I can plug that in where I have this x to the 4th. So doing that, we get negative 1/4 integral from 0 to negative 1. I'm going to plug in for x to the 4th. It's negative u. And then I get e to the u du. Nice. Now the double negatives cancel. So we just get positive 1/4 in front. Integral from 0 to negative 1. U e to the u du. Okay, so now we have this integral to do. And I want to let you think about this one as well. Pause the video one more time for 3 minutes to try this one. Pause it in 4, 3, 2, 1. Pause it and try it. All right, hopefully you paused it and you tried it. It turns out that for this one, u sub isn't really helpful. We're going to need integration by parts. We are going to need integration by parts. Okay, because I already have a u in this integral, I'm not going to call the part u because it might get confusing having a u defined twice. So instead of writing u, I'll write w. I'll have a w and then I'll have a dv. And then, okay, so what should I pick for my parts? Typically, we want this to be something where its derivative is simpler than it. So if I let w be the u, its derivative is definitely simpler than it. So its derivative would be 1, and then I got to write the du. Okay, and then dv is the other stuff, which is e to the u du. So v would be its antiderivative, which is e to the u. Okay, I'll put a thought bubble around this. Thought bubble, thought bubble, thought bubble. All right, so now let's do this antiderivative. I got the 1/4 in front. Big old bracket. Integration by parts will say, well, instead of uv, now it's going to be w times v, which is u times e to the u. Got to plug in the 0 and the -1. Minus the integral from 0 to -1 of v du, or in this case dw. So that's e to the u times 1 du. Close that bracket. All right, so we got this. We got this. We are in business. So let's continue to simplify. Let me move this here. So I got the 1/4 in front. So instead of me plugging -1 and 0 into this, and then doing this antiderivative and also plugging it into this, let me take the antiderivative of this first. And then I'm going to take this piece that I have here, and then this piece that I have here, and then I'll plug the -1 and the 0 overall into that whole thing. So I'll have a big old bracket. The first part is u e to the u minus the integral of e to the u is just e to the u. Close the bracket. And now I'm going to plug in the 0 and the -1 into the stuff in the bracket. The 1/4 is already factored out, so I don't have to, include that when I'm plugging in. So I just leave the 1/4 factored out. Big old bracket. When I plug in -1, I get negative e to the -1 minus e to the -1 minus, now I got to plug in 0, so I'll put a parentheses and then close the bracket. If I plug 0 in, this first term becomes 0, and then minus e to the 0. So this can get simplified a little bit. Let's see, I got the 1/4 in front, bracket. These two terms, so this is, each of these are minus 1 over e. So subtracting them, I'll get minus 2 over e. And then a double negative becomes a positive. And then I get 1 there. And we have 1. Okay, so we got this. We got an answer. So I just need the units. We were finding mass, and the units of mass in this problem are grams. Okay, and there we have it. So one more time, my ending takeaway from this is, when we have integrals, it's important to, sometimes the very first thing that we try, whether it's use of or integration by parts, may not work. And if it doesn't work, that's okay. Then we got to try something different. The best way to get good at this is just to practice a bunch of problems. Like over the course of these videos, I've given a lot of tips of how we can recognize what method to use, but ultimately to get good at utilizing those methods, we just have to do a bunch of practice.